Okay, continuing to talk about probability, the magic word for today is and. So, if we have two independent events, meaning one has no effect on the other, if the events are independent, the probability of A and B is the probability of A times the probability of B. So in this example, we have this roulette wheel here. There are 38 numbered slots, 1 through 36, 0 and double 0, 18 black, 18 red, 2 are green. The ball can land on any slot with equal probability. What is the probability of red occurring on 2 consecutive plays? Okay. The probability of red, then red. Now, what we have to consider first is there any connection or dependency in these events? So what happens is I spin the wheel, throw the ball. What is the probability that I get red? Now, when I take that ball off the wheel and I spin it again, there's no way that the first result will influence the second. So these are two independent events, which means it's the probability of red times the probability of red. And then from there, we can simply use part over total like we did in the previous class. Something doesn't look right here. Yes, okay. So, how many total spaces are there? There are 38. How many red spots are there? 18. Times, nothing is going to change on the second time. The first event is independent. It doesn't have any effect on the second event. So this makes 81 out of 361, which is 0.224, or around 22%. What they've done in the text here is they already looked at the probability of getting red, which is 18 out of 38. They simplified that to 9 out of 19. Multiply those to get the solution. Okay. If two or more events are independent, we can find the probability by multiplying. The probability of a baby girl is 1/2. So the probability of 9 girls in a row is 1/2, used as a factor 9 times, which in English means we're going to multiply it 9 times. But remember, in math, we already have an operation that means repeated multiplication, and that is exponent. So if we want to know the probability of someone having 9 girls in a row, it's 1/2 raised to the 9th, which is 1 over 52, 1 over 512, which is about 0.2%, which is very unlikely, but that makes sense. The odds of someone having 9 children is pretty small. 9 girls in a row is very rare. So here we're talking about hurricanes in Florida. The probability that Florida will be hit by a hurricane is 5 out of 19. What is the probability that South Florida will be hit by a hurricane in 3 consecutive years? What's important to recognize is that these are independent events. Just because you didn't have a hurricane last year doesn't mean you won't have one this year. Likewise, just because there wasn't a hurricane last year doesn't mean you're due to be hit this year. These are independent. So we simply take the probability of a hurricane in 1 year, 5 out of 19, multiply it by itself 3 times. The answer is 0.018, or about 2%. So while hurricanes are bad, the odds of 3 happening in 3 consecutive years is pretty low. Now, let's go back to that other magic word, not. What is the probability that South Florida will not be hit by a hurricane in the next 10 years? Okay, so first of all, we know that the probability of any given year is 5 out of 19. To find not, we simply do 1 minus. So the probability of no hurricane is 0.737, or around 74%. If we want to turn that into over a span of 10 years, this is the probability that there is no hurricane for a single year. We take that same number and raise it to the power 10. Now what we get is a fairly small number, 0.047. Now this is kind of a grim view of things. The probability of no hurricane for the next 10 years is around 5%, which means there's a 95% chance you will be hit by a hurricane sometime over 10 years. Okay. Now everything we've looked at so far has been independent events, where one event doesn't influence the next. If we have dependent events, the result of the first outcome influences the second. So if we have dependent events, we usually a slightly different formula, probability of A times probability of B, given that A has occurred. Now, what the text leaves out here, and they'll show us this notation in just a minute, the probability of B given that A has occurred. We also say this is probability of B given A. But what's important to remember here is that event A happens first and has some influence on event B. Let's look at an example. Three people are randomly selected, one person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. Okay. These are definitely dependent events. We have 5 freshmen, 2 sophomore, 4 juniors. What is the probability that I select a freshman at random, then another freshman, and then a junior? Well, if I choose one freshman, that freshman goes off to the side and the total number of freshmen decreases. So that is dependent. So the probability of a freshman is 5 out of the total is 11. Now, once I choose that freshman, he or she goes off to the side and is no longer here. So really there's 4 freshmen. So the probability that I get a second freshman times 4 out of 10, because there are now 4 total freshmen and the total number of students has also go down to 10. So we've chosen a freshman, then another freshman, and we go to junior. Once that freshman moves to the side, we now have 3 freshmen times, for the junior, there's 4, but the total has decreased again. There's now 4, 7, 9 total people. If we multiply that, to multiply this, multiply all the tops, multiply all the bottoms, and divide. 80 out of 990, which is 0.081, which is roughly 8.1%. So while the numbers are relatively low here, the odds of getting this precise order of freshman, freshman, junior are about 8%. Okay, and this is where the text gives a name to this, and this is called conditional probability. The probability of B given A, where the condition is the results of event A. Okay, a letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome is a letter that precedes H. Okay, so here our sample space are the letters that precede H. Now we do not include the letter H because H does not precede H. So we have these 7 letters here. What's the probability of getting a vowel given that it precedes H? Look at the letters that precede H. There are 7. How many vowels do we have? 2. 2 out of 7. Now these table problems are very common. So here we're looking at 100,000 mammogram screenings, breast cancer, no breast cancer, positive mammogram, negative mammogram. So if you look at what's happening here, the positive mammogram means the test indicates that the patient has breast cancer. This at the top, breast cancer, means they actually did have breast cancer. So if you look at the positive tests, 720 people had a positive test and did actually have cancer. 6,944 had a positive test but did not have breast cancer. So that's a false positive test. Here, negative 80. 80 people had a negative test result, but it turns out they actually did have cancer. This 92,256, this is the majority. The majority of people who took the test had a negative mammogram. There was no breast cancer. So in this problem, find the probability that a woman aged 40 to 50 has a positive mammogram given she does not have breast cancer. All right. We want to know the probability of a positive test given that the person does not have breast cancer. So this is the B, this is the A. Remember, it's A, then B. So what we're saying is, of the people that do not have cancer, how many people had a positive test? Well, if we go back to the table, do not have cancer, that's the total, which is 99,200. Of those, the ones that had a positive test were 6,944. Which is 0.07, which is 7%. So this is the probability of a false positive. They don't actually have cancer, but the test says they do. Okay, and we're finished with the problem. Pay attention to these table problems. They're very common on the homework and on exams.